Let's start with the first problem. Limit as theta approaches 0 of theta times cotangent 4 theta over sine squared theta cotangent squared 2 theta. I'm going to rewrite this in terms of sine and cosine. So cotangent is cosine over sine. And then we have sine squared and then cosine squared 2 theta over sine squared 2 theta. Here I'm going to use a little trick. So in general, if I have a fraction divided by another fraction, I can bring the d over by a and then the c to b. So this would turn into a times d over b times c. So this is a nice little trick that can make our calculations a lot faster. So in this case, I can bring the sine squared up top here, and then the sine squared cosine squared 2 theta down here. So I'm going to multiply this. I have theta times cosine 4 theta, and then multiply that by sine squared 2 theta over, sine squared theta cosine squared 2 theta times sine 4 theta. Okay, now I'm going to rewrite sine 2 theta as 2 sine cosine. So let's see how that looks. And everything else will be the same. So it's theta times cosine 4 theta. And I'll put a parentheses. Sine 2 theta is 2 sine theta cosine theta. And then you square it all over sine squared cosine squared 2 theta. And then sine 4 theta. Okay, now we can start simplifying. We can distribute out this 2 here in the exponent to each one of these. So I have limit as theta approaches 0. It's theta cosine 4 theta. And that will be 2 squared, sine squared, cosine squared. All over sine squared, cosine squared 2 theta, and sine 4 theta. We can do some cancellations with the sine squared. That's gone. So I can rewrite this as limit as theta approaches 0 of, theta cosine 4 theta. And I could put the 4 in front. And then the bottom will just be cosine squared 2 theta times sine 4 theta. And now I can rearrange this. So I can say theta approaches 0. And I can have 4 theta over sine 4 theta. And then the rest will be cosine 4 theta over cosine squared 2 theta. 4 theta over sine 4 theta, that limit goes to 1. I plug in theta equals 0 into cosine, and I just get 1 as my answer. Right, because cosine of 0 is just 1. Okay, let's try an easier problem. Let's see. I have limit as theta approaches 0 of tangent theta over theta squared times cotangent 3 theta. I'm going to change this again to sines and cosines. So I've limited as theta approaches 0. Tangent is sine over cosine. and then I have theta squared times cosine 3 theta over sine 3 theta. I'm going to apply that little trick with the fractions. So this sine 3 theta is going to come at the top, cosine 3 theta is going to come at the bottom, as well as theta squared. So I have limit as theta approaches 0, sine theta times sine 3 theta, and that's all going to be over theta squared, cosine theta, and cosine, let's try that again. So cosine theta and then cosine 3 theta. I'm going to break this up. I'm going to say limit as theta approaches 0. And this theta squared here is going to be broken up into theta times theta. So I'm going to say sine theta over theta times sine 3 theta over theta. And that leaves us with 1 over cosine theta times cosine 3 theta. We know sine theta over theta, that goes to 1. And then here with sine 3 theta over theta, I'm going to multiply the bottom by 3, and then the top with 3 as well. So sine 3 theta over 3 theta goes to 1. And now I'm left with limit as theta approaches 0 of 3 times 1 over cosine theta times cosine 3 theta. I plug in theta equals 0, and cosine of 0 is just 1. So I'm just left with 3 as my limit. Okay, let's do another one. I have limit as x approaches 0, cosine x minus sine x minus 1 over x. Let's rewrite this as limit as x approaches 0. I'm going to combine the cosine and the negative one under one fraction, and then the negative sign into another. So it's going to be cosine x minus 1 over x, and then it's going to be minus sine x over x. We know by now that sine x over x approaches 1, and cosine minus 1, well, we can factor out a negative, and we can rewrite it as 1 minus cosine x over x. And we know this is a special trig limit, which goes to 0. So my limit is 0. Similarly, if we look at limit as h approaches 0 of 1 minus cosine squared over h, we can use that special trig limit by breaking this fraction up. So we can treat it as 1 minus cosine h times 1 minus cosine h, and then we could just put the h over one of these factors. And we know that 1 minus cosine h over h goes to 0, and I don't really care where 1 minus cosine h goes, as long as it's not going to infinity, and as long as it exists, this limit will just be 0. Next, we have limit as x approaches 0, sine squared x over x. We know that sine squared is sine times sine, and I could just put the x over one of the numerators. And then I can say, okay, sine x over x goes to 1. So I'm left with sine x, where, well, as x approaches 0, sine of x also approaches 0. Changing it up, if we have tangent squared instead, we can rewrite this in terms of sine and cosine. So we have sine squared over cosine squared all over x. Now this x is going to come up here. So we'll have limit as x approaches 0, and we can rewrite it as sine squared x over x times 1 over cosine squared. So we have limit as x approaches 0. Now sine squared, we can break it up as sine times sine. So I'm going to have 1 as sine over x, and then sine over cosine squared. And sine over x, that approaches 1. So I can just plug in x equals 0 now for sine and cosine. Well, sine of 0 is 0. Cosine of 0 squared is 1. So my limit is 0. Lastly, let's look at limit as x approaches 0 of sine 2x over sine 3x. Ideally, I want to have sine 2x over 2x and sine 3x over 3x. So let's make that happen. Okay, that means we need to multiply the bottom by 2x. So that means multiply the top by 2x. And then here, we want to multiply 3x to the top, 3x to the bottom, like this. So we're going to have to rewrite this as limit as x approaches 0. And the first one will have sine 2x over 2x. And the other one will be sine 3x over 3x on the bottom. So we can think of that as like 1 over sine 3x over 3x. So that leaves us with 2x over 3x, which if you simplify it is just 2/3. Okay, sine 2x over 2x goes to 1. Sine 3x over 3x also goes to 1. So now I'm left with limit x approaches 0 of 2/3. And we know the limit has to be 2/3.